4 to 5 students join the class now.
Every day. Eh?
Yes, ma'am. Other have, I think, changed the course. We don't have the list till now.
Okay, right. Anyway, 4 to 5 students are available. Jana is here, Zuban is here, Ashwin is here, and Mukesh Kumar is also available. Right. Yeah, let us discuss about the particular electronic device called transistor. We started discussing about transistors, right? So I am going to discuss about the transistors. Basically, there are two types of transistors. Let me share my PPT. Is there any screen is visible?
Yes, ma'am.
Yeah. Yeah. What is available in your screen? Tell me.
Bipolar junction transistor.
Bipolar junction transistor. Okay. Yeah. So we are going to discuss bipolar transistors, junction transistors, because already we have discussed about diodes, okay, PN junction diode and xenon diode. Now, bipolar junction transistors are basically the combination of two diodes, okay, or transistors. Let us say, I think I must have heard about the transistors. Transistors are basically amplifiers. It is used for doing amplification. Say, for example, in communication systems, right? If I am talking to you, the signal or low signals or weak signals, which is to be amplified with the help of the transistors, and it is being communicated over long distances. Okay, so in this case, bipolar represents, there are two different types of charge carriers available in BJT or bipolar junction transistor. One is hole, another one is electrons. So both of these electrons and holes determine the device characteristics. Okay, so it is called as bipolar. And also I can say that there are two junctions in the transistors. Okay, one is I will tell you what is what and all, right? And I can say that the transistors are basically three terminal devices, right? It controls two terminals current. Now I will discuss different types of transistors. Okay, there are I told you there are two different types of transistors. One is PNP transistor, another one is NPN transistor. First I am talking about PNP transistor. In PNP transistor, one second. Yeah, in PNP transistor, this is called PNP transistor. It's another one is NPN transistor. It has three different sections or three terminals. One is emitter. Okay, emitter is one terminal, base is another terminal, and collector is a third terminal. For both PNP as well as NPN transistor, this is the case. Okay, there are three different terminals available. One is emitter. This is called emitter or E. I'll tell you what is emitter, what is base and collector. And another one is base B, and third one is C. So in emitter, in PNP, it is made up of P-type semiconductor. Okay, and base is made up of N-type semiconductor, and collector is made up of P-type semiconductor. But in the case of NPN transistor, emitter is made up of N-type semiconductor, and collector is also made up of N-type semiconductor. In between emitter and collector, there is one base called P-type. Okay, so this is called NPN transistor. Okay, are you all listening? Whether I am audible to you?
Yes, ma'am.
Yes, ma'am.
Yes, thank you. So if you look at the symbol of the transistor, diode can be represented like this, right? There must be one circle and one line. So this is your diode, right? I told you there are two terminals. One is anode, another one is cathode. Even though cathode is represented as CATHODE, And normally we represent these letters by A represents anode and K represents cathode. Okay, this is a diode. Now here in BJT or bipolar junction transistor, you see the symbol will be like this. Maybe you must have studied in your physics, okay, or in +2. You see, this is your emitter. Emitter means there must be one arrow which can be represented as emitter, and this is your base, and there must be one collector. Okay, this is normally the symbol of any transistor, right? And this arrow, maybe it is inward or outward depending upon the type of PNP or NPN transistor. So, for example, if you consider a PNP transistor, we consider this as a PNP transistor. Okay, PNP means what? Emitter is made up of p-type semiconductor, collector is made up of p-type semiconductor, and base is made up of n-type semiconductor. Okay, you know, the current direction you can represent like this. P means inward. Okay, so in the PNP transistor, PNP transistor, okay, PNP transistor, the current direction will be going like this, not this one. Okay, but in the case of NPN transistor, you know, I can draw the symbol of NPN transistor now. Sorry. This arrow. Yeah, I will draw one NPN transistor. I will draw one NPN transistor here. Okay, in NPN transistor, emitter is made up of N-type, collector is also made up of N-type, and base is made up of P-type. Okay, and the current direction is like from here to here. Okay. Yes. Now, if you look at the structure of the transistor, this is the case. Structure in the sense what? It's a 3-terminal device. You know, it has got 2 junctions. Okay, bipolar junction transistor. From the name itself, we can say that it has got 2 junction. Junction in the sense, one is emitter base junction. This junction is called as emitter base junction. This is the junction, and here base collector junction is another one junction. So we can say that this is a 3-terminal bipolar junction. Why it is called as 3-terminal? It has got 3 terminals. One is emitter, another one is base, and third one is collector. So there are 3 terminals, not only for PNP transistor but also for NPN transistor. And here in PNP transistor, the current conduction is mainly due to holes because it has got a more number of holes. Base junction, base is a very small junction. The width of the junction, the width of the base is very less compared to the width of the emitter or collector. Width means what? This width I am saying. See here, look at the width of the emitter. Okay, from here to here. Look at the width of the collector. Please unmute your mic and tell me what about the width of the collector, whether it is more than the emitter or less than the emitter. It should be more than the normally collector normally collects the charge carriers. Emitter emits the charge carriers depending upon the potential what is being applied across the junction. You know. Okay, so here in PNP transistor, the current conduction is mainly due to holes. Holes are majority carriers. Okay, P plus represents there are more number of holes in emitter. Okay, P represents, of course, holes available in the collector. Okay, so it's a semiconductor. It's also a semiconductor. In between these 2 p-type semiconductor, we have the n-type semiconductor. Okay, so I can just structure it like this. Like it has got a bar of semiconductor. Okay, the entire thing is a bar of semiconductor. At the end of the semiconductors, we have p-type impurities which are more doped, and at the center it is like n-type semiconductor. Okay. Now, if you look at the NPN transistor, holes are minority carriers, only the electrons are majority carriers, right? So here also it has got three terminals: emitter, base, collector. Normally, emitter is the terminal where more carriers will be emitted. Okay, or we can say that emitter from the name itself, I can say that emits the charge carriers. In NPN transistor, emitter emits electrons, but in PNP transistor, emitter emits holes. That is the only difference. Okay, collectors are basically collecting the charge carriers. Okay, so the charge carriers may be attracted or repelled or recombined among each other. Finally, it will be collected by the collector. So the name itself is called as collector. Here also it's a collector. Okay. So how will you differentiate this NPN and PNP transistor? Any idea? Please unmute your mic. Zuban, Zana, please tell me.
Yes, sir. Yes, ma'am.
Yes, how will you differentiate PNP and NPN transistor? I am talking about two different types of transistors. Okay, one is PNP, another one is NPN. Just I am asking you to differentiate these two transistors, or just tell me the difference between these two transistors.
Ma'am, base of PNP transistor is of N-type. The base of NPN transistor is of P-type.
Not only base, even the emitter is also different. No, in PNP transistor, emitter is P. NPN transistor, emitter is N. That is N means N-type semiconductor. Even the collector also, right?
Yes.
Then another one point is here holes are the majority charge carriers. See, from the name itself, I can say that it's a bipolar. Bipolar means what? It has got two different types of charge carriers, two different polarity. Okay, one is positive, another one is negative. So here, there are two junctions, PN. Here it is NP. Conduction of current is due to holes, but small amount of carriers are since electrons are available as minority carrier, current conduction is also due to electrons, right? So the major charge carriers are holes and minor charge carriers are electrons. But here in NPN transistor, it is reverse. Majority carriers are electrons and minority carriers are holes. Understood?
Yes, ma'am.
Then if you look at the symbol of the transistor, okay, in NPN transistor you see NPN, right? There must be one arrow pointing outside, which shows, okay, and here it is actually. I will explain this current flow in another one diagram. Okay, now here in a PNP transistor, the current flow is inverse. So I will explain the current flow, how the current will be flowing because of the application of bias. Okay, that will be discussed in the next slide. Any clarifications here? If you have any doubts, please let me know. Otherwise, I'll move on to the next slide.
No, ma'am.
Here, what I am trying to say is there are two different types of PNP transistors. That is, bipolar junction transistors are available. One is PNP, another one is NPN. Okay, that only I'm trying to say. And in PNP transistor, okay, emitter is made up of what? Collector is made up of what? What type of semiconductor is being used? Similarly, base is made up of what type of semiconductor? And it is reverse for NPN. Okay, if you look at the width of the collector, it is more because more carriers will be collected by the collector. It is more when compared to the emitter. But when compared to emitter and collector, the base width is very small. Okay, it's a very small. And also I can say that it has got two junctions. Okay, PN is one junction and another one is NP junction. Now even I can say that it's a combination of two diodes. Am I correct? Why we can say that it's a combination of two diodes? See, it's a PN. Okay, here it is P, this N. Then this side, another one. This is P N. This is PN. So two diodes are back to back connected to get this PNP transistor. Okay, so this is the equivalent circuit of this particular PNP transistor using two diodes. PN is connected, okay, with another one, NP diode. Here I can draw like it's NP, N, this is P, NP, then this is PN. Are you able to understand? Yes, boys?
Yes, ma'am.
Yes, ma'am.
Okay. See, since only very few students are available, I want some kind of response from your side, okay? Right? So that it is interactive. Right. Now let me discuss the configurations of transistor. What is BJT? Bipolar junction transistor. It has got its own configurations. Okay. Now let me consider a first type of transistor called PNP transistor. Okay. What is PNP? PNP is one type of transistor. P is emitter. This is emitter. Okay. This is base, and this is going to be the collector. So I'm considering only PNP transistor in all these configurations. Okay. The same thing is applicable for NPN transistor also. So in PNP, that is the first type of transistor. Here, I can say that this is a base. Base is common. Common means what? Common to both the input. Let me consider this as the input side, and this is the output side. What is input? What is output? Normally, maybe if you pour some water to a plant, okay, it will grow. It produces some output. So like that. So input is the water. Output may be the fruit. So input will be given at this side. Okay, that is called as input side. Or I can say that I'm talking to my input signal. That is my audio signal may be available, or it may be kept here, and you are able to get the output. That is amplified output may be taken at the output side. Okay. So so this is what. So it's called as a common base. Base is common to both input and output. In this case, it's a common emitter transistor. So here emitter, this is your emitter. Emitter is common to both input and output. Okay. So inputs are has to be connected between base and emitter. Output can be taken from collector and emitter. In the case of common collector configuration or common collector transistors, this is your collector. Collector is common to both input and output. Are you able to visualize what I am trying to say? The configurations of transistors. Please students, please unmute your mic and tell me.
Yes, ma'am.
Yeah. What do you understand from this configuration?
Ma'am, different ways to use the transistor.
Yes. Very good. Okay. There are different ways of using the transistor, of course. And the major applications of this transistor is amplifier. Okay, amplifier means what? Maybe the input signal given to the transistor is in terms of millivolt. Maybe I will say that 1 millivolt is given as the input of the transistor. Okay, at the output in the sense here. Okay, at the output, you will be getting some 100 millivolt. Okay. Depending upon the parameters, what is being used, resistors, okay, whatever may be the thing which is connected over here. So let me say that this is the input signal and this is the output signal. So after amplification, basically the transistor is acting as an amplifier. It has got very good gain. Gain means what? Output voltage divided by the input voltage. Okay. So input voltages are connected across emitter and base. So this particular signal with the help of the function generator which is available in our lab. Okay, so that may be connected between emitter and base, and the property of the transistor is it is used to amplify the signal because of the current flow that I will explain right now. And I can take the output the help of one CRO. CRO means cathode ray oscilloscope. It's a device which is available in our lab. So with the support of CRO or voltmeter, whatever it may be, you can take the output. Okay, now here the amplification factor also you can say output voltage divided by input voltage is nothing but the amplification factor or gain. Gain means what? gain, capital GAIN. I'm writing gain. Gain is equal to output voltage. Maybe V naught. Let us say output voltage divided by the input voltage VI. So V naught is nothing but 100 volt. So gain will be equal to, say for example, if you consider the output voltage as V naught, or it is equal to some 100 millivolt, okay, divided by the input voltage is 1 millivolt. What is the gain? Can you tell me what is the gain? Gain has no unit, okay. So 100 divided by 1 is equal to 100. 100 is the gain. 100 times it is multiplied, or 100 times it is amplified. Understood?
Yes, ma'am.
Okay, now let us see how it is doing amplification. The process I did not explain. Okay, because of the application of the potential, what is the process, how the current will be flowing, okay, what will be the movement of the charge, that and all I have not explained. What I explained? In the common base configuration, okay, if the input voltage given to the transistor is 1 millivolt and output may be 100 millivolts, if the output voltage is 100 millivolt, what is the gain? Okay, the gain is the output divided by input, or output voltage divided by the input voltage. So this is for just for example only. 100 millivolt divided by 1 millivolt will give you 100. This is a gain, or we can say this is an amplification factor. 100 times the input voltage is amplified by this transistor. Okay, now this is in common base. Similarly, I can say that in common emitter configuration also I can feed the input, that 1 millivolt input between these two, that is base and emitter. Okay, now again, because of the application of the potential, okay, some current will be flowing, recombination charge carriers will be taking place, even the carriers will be moving forward, reverse and all, right? And here across the collector and emitter, we can take the output. Output maybe this is like some 80 millivolt or 120 millivolt, depending upon the configurations. Also, depending upon the configurations also, the gain may vary, or depending upon the parameters which is being used, resistor. Okay, so that and all we can design. Design of electronic circuits will be based upon the specifications. Okay. So only thing is we will be getting the output voltage, right? Gain can be calculated accordingly. So here in this case, maybe if the output voltage is some 110 millivolts, okay, 110 divided by 1 millivolt, maybe the gain is 110 is the gain, right? And in common collector configuration also, you can feed the input between what is called collector and base. If you feed the input between collector and base, naturally current will be flowing, and we can take the output across emitter and collector. Okay, it's one kind of common collector configuration. And here also, if the input voltage is 1 volt, output maybe some 100 volt or 200 volt, whatever it may be. Okay, so accordingly we'll be getting the gain. So these, what I'm trying to say, these are the different configurations of BJT. Okay, different ways of connecting the terminals of bipolar junction transistors, right? Common in the sense, even if you do the electrical lab or electronics lab, physically you can understand. Okay, the devices must be connected to a common point that is called as ground point. Even in electrical connections, okay, near home, right, earthing is done. Okay, so all sort of things has to be connected to earth, then only the current will flow, right? So that sort of thing. So all the one of the terminals should be connected to a common point. Okay, that is called as ground. Okay, so here directly the base is grounded. Here directly what is called emitter is grounded, and here the collector is grounded. Right? Or I can say that it is common to both input and output, both are same, right? So in common base configuration, base is connected to ground potential. Common emitter configuration, emitter is directly connected to ground potential, and collector configuration, collector is directly connected to ground potential. Okay, so this is what the configurations of BJT. Now let me explain the operation of these configurations one by one. Yes. Yeah, let me consider one common base transistor. Okay, so here I am trying to connect the battery. Normally, you know, emitter base junction should be forward based for proper current conduction in common base configuration. Emitter base, this should be forward based, and collector base configuration should be reverse based. Okay, I'll tell you why it is being forward based, why it is being reverse based. What is called forward bias? Subhan, you have any answer for it? What is called forward bias?
Ma'am, when current flows from positive terminal to negative terminal, it is called forward bias.
No, no. Forward bias in the sense biasing. Externally, we are applying some voltage. Okay.
Yes, ma'am.
Say for example, if you consider one P, connect like this. So this is if it is P, if this is N, okay, connecting positive of the battery to P type. So here battery has two terminals, right? Am I correct?
Yes, ma'am.
Battery
Yes, ma'am.
has two terminals. One is positive, another one is negative. So connect the positive of the battery to P type. Then connect the negative of the battery to N type. This is the negative of the battery that is being connected to N type, and positive of the battery is connected to P type. This is called forward bias. It is not like potential or movement of charge carriers. Okay. So once it is being connected, current flows. That we will explain. So this is called forward bias. Understood what is forward bias?
Yes,
Understood
ma'am.
what is okay. So connecting positive of the battery. This is called positive. Positive of the battery to P type, and negative of the battery to N type. This is what is called forward bias. So what I'm trying to say, in the transistor, you look at the leftmost corner of the transistor. See here, I'm going to connect some battery across these two terminals. How will I connect? How will I connect the battery? I will change the ink color. So here, I'm going to connect positive to emitter, negative to base. Understood? See, I need response, otherwise I will not proceed.
Yes, ma'am.
Yes, ma'am.
Yes. So it's an emitter. It is made up of P-type semiconductor because we are talking about P and P. Right now we are not bothered about NPN. So in PNP transistor, okay, emitter is made up of P-type. Of course, it has got heavily doped impurities because it emits electrons, right? Sorry, holes, right? So here, this positive terminal is connected to P-type. And this is what negative or N type. N type is connected to negative. So this is called forward bias. Understood? Yes, boy. Connect negative of the battery to P type. This is what negative. Negative of the battery to P type. And positive of the battery to N type. This is called reverse bias. Okay? Is it okay for you?
Yes, ma'am.
Yes, ma'am.
Yes. So at the other side, at the output side, or at this end, you connect negative of the battery, then positive to here. Of course, this must be grounded. Grounded is represented like triple data, something like this. Understood? Now, let us see how this particular PNP transistor works. Okay. Shall I proceed?
Yes, ma'am.
Yes. Now here, because of the application of this forward bias, okay, the operation is quite similar to diode. Okay, because I'm talking about only PN junction. Okay, so here, since positive of the battery is connected to this particular P-type semiconductor, naturally the holes which are available in the emitter will be repelled by the positive terminal of the battery, and they are trying to move towards the base because base has electrons. See, normally holes sometimes may recombine with electrons, Okay, and say for example, if there are some 25 holes may recombine with the 25 electrons, right? But 1 or 2 electrons will be there again. Remaining holes which are available in the emitter, because emitter has more area than base, so remaining holes will be attracted or crossover. Okay, they are moving towards collector, right? They are moving towards collector, and few of the holes will be moving towards like this. See, partly it is moving towards collector, and few will be attracted by the negative terminal of this battery, and they are moving like this. So that, see, the holes are moving like this, and the conventional current direction is equal to the direction of flow of holes. So I can say that some hole current will be flowing through this particular input side. That is called as IE. I'll repeat the same thing. You please try to follow me. See here, I'm talking about the forward bias. Forward bias is applied across this particular PN junction. Okay, where emitter is connected to positive of the battery and base is connected to negative of the battery. I'm talking about only this input side. Okay, now here the electrons are the holes are attracted by the electrons which are available at base, and it is being repelled by the positive terminal of the battery. Okay, and they are moving towards, these holes will be crossing over this particular junction. At that time, some of the holes will be recombined with electrons, and remaining holes will be crossing and moving towards the negative terminal of the battery. Okay, this is one side which constitutes what is called emitter current, and few of the holes will be crossing towards the collector also. Okay, which may be constituting what is called collector current. I'll explain this operation a little later. First, let me clarify this one, input side. So because of the forward bias, some current will be flowing through the emitter base junction. Understood? Able to follow me?
Yes, ma'am.
So this whole current, IE is the emitter current, which is due to holes. So this current is called hole current or emitter current due to the application of forward bias. Okay. Now let us come to the output side. Okay. Now here, as I told earlier, this is reversely connected or reverse based. Collector base junction is reverse based. So P-type semiconductor is connected to negative of the battery, and this N-type is connected to positive of the battery. Now here I can say that these holes which are available in the collector side and few of the holes which are crossing over this particular junctions. Okay, so those holes will be attracted by the negative of the battery, right? And again here some recombination of charge carriers will be taking place between the holes and electrons, and we don't bind about that kind of charge carriers. Of course, it will constitute minority carrier current. Okay, now we are talking about the majority carrier current. Majority carriers are holes. So these holes will be moving towards the negative of the battery, and there must be some hole current is flowing through the junction. Okay, that current is called collector current. Okay, the current direction is normally the conventional current direction. Conventional current direction is due to electrons in NPN transistor and holes in PNP transistor. So here the whole current will flow, which is almost equal to the direction of flow of conventional current. Okay, so IC will be flowing through the junction. So what I'm trying to say, the current which is flowing through the emitter is called emitter current. Current which is flowing through the collector is called collector current, and the current is flowing from the base is called base current. So there are three different types of currents I can say. What are the currents? One is IE, which is your emitter current. Another one is IC, which is going to be the collector current, and third one is IB, which is the base current. Okay, if you look at the amount of current or quantity of current in IE, IC or IB, the IC is more. IC is more when compared to base current, because the width of the base is less and width of the emitter is also less. Are using KCL or KVL. Have you heard about KCL? What is KCL? KCL is Kirchhoff's current law. Current law. Yeah. So here incoming current is equal to the outgoing current, or at this point incoming currents are IE and outgoing currents are IC. So emitter emits a current. So I can write the equation as emitter current is equal to IE is equal to sum of collector current and the base current. Emitter emits the current. Collector just collects the current. Okay. So IC plus IB is your emitter current. Okay. So this we can derive from this particular thing. Understood?
Yes, ma'am.
Yeah. So just I have briefed the operation of one PNP transistor with the application of external voltage, okay, external forward bias as well as reverse bias. Now let us discuss the operation of NPN transistor in the next class. Okay.
Okay, ma'am.
Yeah, 1 second. You please give your attendance and go. Subhan, Jana, Mukesh, and Ashwin is available. Okay. Yeah, thank you, students.
Thank you, ma'am. Have a good day, ma'am.